Hello, and I want to welcome you to a discussion on the properties of logarithms. So let's get started. We have several properties to go over. First, there's the product rule, and the most important thing that you want to gather from this slide is the following. That a log base of b, and then you have m times n, where though m and n and b are positive real numbers, where b is not equivalent to 1, you can actually break it down into two pieces. Log base of m, or b, m, plus log base of b, n, being separated by the addition. So if we look at these examples, log base of 4, then we have inside parentheses 7 times 5. So what we can do is say the following. We can just say log base of 4, 7, plus log base of 4, 5. And that is an equivalent statement. Okay, with number 2, we have log, and remember that's an unspoken base of 10. Then we have in parentheses 10x. So we just break that into log of base of 10, 10, plus log base of 10x. And this can be simplified even further, because log base of 10 just equivalent to just 1, plus log, and you don't have to write that 10 now, just x. And that is an equivalent statement. Okay, next we're going to talk about the quotient rule. And the most important quotient rule artifact you want to gather is the following. Log base of b, where you have a fraction m divided by n, equals log base of b m minus log base of b n. Notice that the numerator and denominator are being subtracted, and not fractions this time, but they're being subtracted. Where b, m, and n are real numbers that aren't, where b is not 1. So we have examples like number 1, log base of 5, and then in parentheses 20 divided by y. So we can break that into is log of 5 with 20 minus log base of 5y. And that is an equivalent statement. Okay, but number 2 we have ln. Remember we have an unspoken base of e, and then parentheses e to the 4th over 8. So what we can do in this case is say ln, and let's note that that's base of e to the 4th minus ln 8. And if you notice, the ln base e and then the e will cancel out, just leaving you with the power of 4 minus ln 8. Looking at the next slide, we're going to look at the power rule. And the power rule defines the following, where we have log base of b, where we have m to the power of p equals p pulled out in front, log base of b m, where b and m are real numbers and b is greater than 1, and p is any real number. So with our examples, we have log base of 4, 9 to the 5th. So we can actually take the power of 5, pull it out in front, leaving us with 5 log base of 4, and then leave our 9 there. Next, we have ln cubed root of x. So just write ln, and then first what I recommend doing is write the variable as a power. And remember that x has a power of 1 inside, and the stuff inside of the x stays in the numerator, and the stuff on the outside of the radical comes as the denominator. So we can write cube root as a 1/3. So we have ln x to the 3rd. 1/3 power. So we can actually pull the 1/3 out in front, leaving you with 1/3 ln x. Okay, next we have log 3x. Now that's being raised to the 6th power. So let's take that 6 and pull it out in front. So we have 6 log 3x. And to conclude this video, we have these examples. Use properties of logarithms to condense the logarithmic expressions. Write the expressions as a single logarithm whose coefficient is 1. Where possible, evaluate logarithmic expressions. And this is going to gear us towards the next section, which will involve equations with logarithms and exponentials. So we have log 4 plus log 5. And if you refer to our properties, this plus is telling us since the logs are the same, have the same base, that unspoken 10, we can actually bring these together and under multiplication. So taking the same base, bringing down just log, and in parentheses we have 4 times 5, and that can actually be simplified just doing the multiplication of log base, that unspoken 10, and then just 4 times 5 is 20. And that's the answer. Okay, next we have this subtraction, and if you note, our logs and bases are the same, so bring our log base of 3 down, and this subtraction here between the two sections tells us it's going to be division. So let's bring the first piece as the numerator and the last piece as the denominator. So we're going to have 3x plus 12 on top. Sorry, this computer is messing up a little. And then we have 2x on the bottom. And that is our answer. Okay, with number 3 we have 5 ln x minus 6 ln y. So we can note that these out in front can become exponents to our variables. And then we have this subtraction telling us there's going to be a division. So first things first, let's write ln with our variable raised to the power of 5 minus ln power of y raised to the 6th. Now we note our subtraction here. So we have our same ln. Now we can take our first piece and our second piece, with the first piece being the numerator and the last piece being the denominator. So we have ln base of unspoken e with 5x to the 5th over y to the 6th. And that concludes this section.